This is going to be part 3 of our light switch tutorial, and we're going to be going over making our light switch work in a multiplayer environment. So as it stands currently, when let's say our character here, our server, or even a client will turn the light switch on or off, that's only happening locally on that client. If we have client 1, client 2. If client 1 turns the light on from an off state, then client 2 will see the light is off, but client 1, the person who turned it on, will see the light as being on. So it's not being replicated through each and every client. And that's what we're going to be resolving in this video, as well as a couple other little things. Now, first off, for example, as you can, just like before when we play, press E, our ray trace we're running. But let's say we have another client here, 2. Press play, our server, it's still working just fine. But if we go over to our other client and we press E, nothing's happening. Now this is because we have our character here and we've added our ray trace component directly to this character that's just in the world. Think of it as this object. The ray trace, our component, is only active or on this specific character. When another one spawns as we add more and more clients, they're not going to have this ray trace component. Now what we can do to fix this is go into our project name, our third person CPP, go to blueprints, third person character. Then over here you should see viewport. And if you get a little option somewhere like a screen to say open full blueprint editor, click that and you should have viewport. If you do not, go to window, make sure you have everything checked similar to how I do, viewport and components being the main ones. Let's go ahead and collect our little character, drag this window down so we can get just a little bit bigger. Let's see. So here, as you can see, it's very similar to what we've clicked on in the editor window behind us when we click on our character. This is what's going to be loaded by default. So, for example, on my character that's already in the world, if I go ahead and delete this ray trace component and go to our C++ classes, add our component to the blueprint, compile, and save, you'll see ray trace, our component, is now inherited. So that pretty much means we can delete this guy even, just like we did with how our client spawned in this character wasn't being used for our client on the, let me start over. This character was being used as our server because it's already placed, but our client was something completely separate. Now when we have both, just like before, our client did not have the ability to use our ray trace function, he will now, because any extra clients that spawn in will have this component on our character. So I'll just leave it at that because I'm kind of rambling on and on at this point. So now you might think it might work. Well, it's actually not going to. As you can see on the server, it's working just like normal. But our client here, even though he has, as I'm pressing E, the component on him, I press F8 and go to him. He has our component here. It is not working because we need to add a little bit of a delay. Not sure what the actual reason is, but for clients, just kind of on begin play, where essentially where we have our component, we're going to make a separate function to add I am in the wrong file. We're going to make a separate function to set up our player components, and we're going to have that on about a second delay or so. So once we load into the map, after about a second, it's going to set up our components. And from there, you'll see our client's going to have the ability to use our ray trace, and in turn, operate our light switch. Now, what we're going to be using is what's called a timer to pretty much delay our function, our function call. And on our function, we're going to be setting up our components. So for starters, I want to go ahead and create a new function. that actually does that for us. Call it void setup components. Oops. Void array trace setup components. Drag all the stuff that we put inside of begin play in here. Now what we're going to need is, well, we're going to be using our timer manager, and in order to use it, we need to include this header here. Now, if we scroll up a little bit, you can see which type we're going to, well, what constructor we're going to be using. We're going to be using set timer. And as you can see, one of the things that it takes in as a parameter is a handle to our timer. So that, I'm going to go ahead and add that, well, this header to our ray trace header. And then you can see the type, well, the first parameter is an F timer handle. So I'm going to go ahead and add that in here. F timer handle, timer handle. Now inside of begin play, we're going to be using this timer with set timer to have a pretty much a delayed call to our setup components function. We're going to be going off of get world get timer manager dot set timer. Dot set timer. Now first thing, timer handle, then our object, so this, the function we want to call, array trace, setup components, the delay that we want it to be, so like I said, about a second, so I'm just going to do 1.0. Then at the end, just add false, because we do not want this to continually repeat. We just want it to run once and pretty much kill itself. So let's go ahead and build this. Then once this is done, when we run it, we should have our, well, any clients that we add on top of this one, they should be able to use, well, we should be able to see the line from our ray trace function being called. Alright, here's our client. Press E. As you can see, our ray trace function is being called just like so. Same thing just like before with our server. Now back to the one issue I wanted to discuss. Here's my server. He's aim at the light. Here's the client. When the client runs up to the switch, presses E. If I can hit it. As you can see, the light for the client is on, but not for the server. Off, on. And it's the same thing for the server. On, but it's not on for the client. Here's what we need to use RPC. Now if we scroll down a little bit, or actually it's right at the top, we have a couple different types. The first one being client. So this will be, like, let's say we have a function, and this function we want, well, it's going to be on the server, so it's only going to be running on the server. Well, called on the server. So called from the server and ran on the client, sorry. Then if we have the keyword server, it's essentially the opposite. So we have from our player controller, such as our client that we were just looking at, he can call a function that gets ran on the server. So if we wanted to use net multicast, which runs just on all clients, we would use, and we wanted to call it from a client, we would use this setup here, which would be running a function on the server. Then from this function, we would have it call our net multicast function. So we're calling from the client to the server, then from the server, well, that server is going to be calling our function, which is going to be a type net multicast, which is going to run it on all the clients. That was a really probably a bad explanation, but you'll see it as time goes on. So if we scroll down a little bit, you can see the setup here. So the first thing that we're going to want to do is actually going to be in our ray trace. If I drag this to the side, we're going to make a U function. So we want this to run on the server. So U function, keyword server, and we need with validation. Then we have the name of our function. One thing I forgot to add is you will need to include the Unreal Network header at the very top. I don't know why I keep typing it when I copied the whole thing. So now we have our, well, we need to make our server. Well, our function prototype that's going to run on the server. So void server, let's see what to call it. Call light toggle. That'll work. So now, if you read here, well, first off, when you call a function on the server from a client, it always has to have a validate function. Then the implementation function is what actually gets, well, ran. So we call some RPC function just like we would a normal function. From here, it's going to check if it's valid. So as you can see, if the amount that add health was passed into is greater than whatever they set their max add health value to, it's going to return false, which means the implementation function is not going to be running. But if it's less than the max, then it's going to return true, which is going to allow the implementation function to run, and in turn, it's going to add health to that player. So we're going to be doing the same thing here. We have server call light toggle. Go ahead and type copy implementation because I keep spelling it wrong. And we're going to go over here to our .cpp. And I'm going to do this right below our setups components. The void u ray trace. Completely forgot what I called it. Server call light toggle underscore implementation, as well as bool u ray trace server call light toggle validate. As you can see now, we're set up just like so. So for our purposes, we're just going to always return true, just so we can, for testing purposes. And let's go ahead and build. You have these red squiggly lines here, you're still going to be good to go. Guess what it's doing? What now? Oh, wait, no. Oh. It also has types. So in our case, we want it to be, scroll up, reliability. So since we want it to happen pretty much immediately, we want it to be that is reliable. So reliable. Let's go ahead and build. Once this is done, we can go ahead and begin, well, setting it up so we can call it. Yeah, man. There we go. So when we press E, we call our toggle light switch function. So we have essentially what we want to check here, so we can know that it is in fact a light switch. What we're going to be doing is taking our light switch, passing it in to our server function, And inside our validate function, we're going to be doing pretty much this check. So if it is valid, then we're going to return true. If it's not, return false. So that way, it's just a clean run. So we can set this up. Actually, let's go ahead and copy the type variable and add it to our prototype and rest of our function as parameters. So in our validate function, we're going to have it as if light switch equals null pointer, return false, else we're going to return true. Then in here, we're going to call it. So server call light toggle. And let's go ahead and print out a log. UE log temp warning text running on server. And Control Shift B. And I forgot to pass in light switch. So go build, cancel, and just rebuild the solution again. Ready? Go over here. I can hit it. There we go. As you can see, when I press E on it, it says running on server. So we do know that our implementation is running, even though we just called, well, as you can tell, it already kind of sets everything up for us. So from here, we want to call another function on, well, that we're going to have written here in the light switch. And what this function is going to do, it's pretty much going to run all of the code here on our clients. The only difference is we're going to make this variable here, we're going to make this variable replicated. So it's the same on each client. So to give you an example as to why, let's say this variable is not replicated when, let's say we have a join in progress player. So we have client 1 who's been on the server, well, client 1 and client 2 have been on the server at the same time from the very beginning. And client 1 turns on the light switch. Well, since this function is going to be running on each client, that means client 2 will see that the light switch is on, just like client 1 sees that its light switch is on. Now let's say client 3 joins the server, and the light switch was off by default, just at the beginning. Well, client 1 and client 2 are going to see the light as being on, but client 3 is still going to be seeing the light as being off, just because this function hasn't really run, or if it does run afterwards, there's a chance that that could be out of sync for client 3, who was a join in progress player. So that's why we want to have this replicated. Okay, I'm recording this little section about 3 days after the whatever you were just saying. So I believe we left off at talking about we're going to be replicating this variable here. So when it does replicate, it's same on all clients no matter what, or it's just always going to be the same. So from here, remember if I went over it, when we do find that we did in fact come in contact with our light switch when pressed E, we're going to call all light toggle, and this function is only going to run on the server. So this code here that I'm highlighting is only going to be ran on the server. So what we want to do from here is we want to go from this server function to another server function, well, just another normal function over here that will in turn alter our replicated variable, this one, and call our onRep function. So when we change it, we call that, and it runs on all clients. So it pretty much indicates that there was in fact a change, and it's going to be all of this here that gets ran on the clients, well, and server. So what we can do is we can go ahead and set that up. So I want to go ahead and actually change this to light state, since that's pretty much going to be a better representation of the name, and I did not click the CPP. There. And that should be it. And now we need to make it replicated. So what we would do is, it's a U property, so U property replicated using, and here's where we would indicate which function we want to run, well, if that's going to be running when this variable is replicated. So in order for it to know what it is, it has to be a U function, so U function. Here's where we can give it our name, so void on rep light toggled. Decent name. Now we need to control it from the CPP. So first off, since this is going to be using some networked stuff, we want to include Unreal Network. So include net/Unreal Network. And here's where we need to set up our replicated variable, or this one. So just to save annoying typing, this will be in the description as well. Just copy and paste. And you'll see here we need to make some changes. So what it is the do rep lifetime is pretty much what class it's in, as well as the variable that we are replicating. So this will kind of indicate that it's, well, set up to replicate. That makes sense. So light state is our variable, and replace my class with our class. Now let's go ahead and finish our little function here. So we wanted to use on rep light toggled. Now we need to set up our on rep function. A light switch on rep light toggled. And now we should be safe to go ahead and build without any issues, just to make sure we're not overlooking anything. I want, for when we do call from our server, I want to set it up so we just call toggle light, and toggle light handles everything that we need. As you can see, we're good to go. And since this onRep function is going to be what runs on all clients, we want to take what is inside of toggle light and put it in our onRep function, just like so. And since our server, like I said, I want it to be calling toggle light, we would do everything from here. But first off, I want to make 100% sure that it is in fact the server that is running this function. So we need to do a check if we make sure we have authority. So if has authority, we want to first alter our light state variable. So light, we actually need to pass in our light switch to that function. So let's go ahead and add that as a parameter. A light switch. We do light switch light state equals the opposite of light switch light state. So now that our variable is altered, we want to call our onRep function. So onRep light toggled. Now let's set it up so we call this function when we hit our light switch. I want to change this so it's a little more clear here in a second. Running from client. So light switch, toggle light, and pass in light switch. So now we're pretty much set up, but I want to point out something. Since we are in fact altering that variable inside of our toggle light function on the server, we want to keep it that way so it's not changed on the client. So in our onRep function where we alter our light state variable, we want to remove that since we don't want that to change from from ourselves. We want it to have what value the server essentially assigns it to. So I did call it right. Yes, okay. Let's go ahead and build. And we are missing one thing, which I will show you here in a second. So this will not work exactly right. What should happen is the server should be able to turn it on and off just fine and see the light change. But the client will not be able to see that light change. And when the client interacts with the light switch, the server should see the light change, but the client wouldn't either. A little confusing to wrap your head around, but you see on the right here we have the client that I'm controlling now, and on the left I have the server. The server just turned the light on, client doesn't see it. Server just turned the light off, client doesn't see it. Now if the client turns the light on, just like so, well, the client doesn't see it, but it's running on the server. So what we need to do to fix that is we need to actually set our light switch up to be replicated. So that's very simple. It's literally b replicates. Just set that to true and build it. There we go. Now when we run it on the server, as you can see, it is also on the client. Oops. Should I get this guy out of the way a little bit? Now if we turn it off from the client, it turns off just like so for everybody. So you can toggle it on and off from the client without any sort of issue. That'll work with several clients. I doubt this is going to fit very well on the screen. Right, so that one can be seen. This will be the guy that alters it. And yeah, that's visible. So as you can see, well, actually it's not visible. But as you can see, client 2 is altering it. Client 1 is seeing it, as well as the server below is seeing it being altered. So it is replicating across all clients and the server properly. So one little thing that you're going to want to do is in our ray trace, well, since we have it set up so we call light toggle our function from the client to run on the server, if we're already the server, we can actually skip this entirely. We don't need to run from the server, call a server function, just so it runs on the server again, essentially. So all we need to do is, actually do the most likely one first. If does not have, how do I spell this? Authority. What? Wrong. As authority. We call it directly. So light switch, toggle light, fasten light switch. Get owner as authority. Yeah, that's why I wasn't going off of anything. Let's switch these around. My stupidity. So if we are not the server, which is going to be the most likely option since you're generally going to have more clients and, well, the server is not going to be one-on-one, we want to call our function from the client to run on the server, which will print out this text here as I'll show you, and which turn from the server then calls our toggle light, which, well, does everything to toggle our light. Now if we are the server and we press E on the light, then we're going to skip this step. We're just going to toggle light directly, since we're already the server, so that's okay. So just to show you, go ahead and clear this. Move these up. So from the the server, press E. Why does it say running from client? Client. This is because I'm on a LAN. Well, I'm just going to assume that's why. But I'm not 100% sure since I'm running essentially from one process, I believe. But anyways, that's the logic behind it. It's relatively simple, and that should have hopefully been a good introduction to both using RPC to run functions on servers and clients. Well, we haven't run anything on the client, but it's the exact same thing, as well as replicating variables and being able to control what happens, well, when our variable gets altered. So, hopefully that was informative. If you have any suggestions on things to change or improve upon, or what you would like to see, just comment, and I'll see you in the next one.